In this video we're going to talk about solving absolute value inequalities. Before we move to absolute value inequalities though, let's go ahead and refresh ourselves with absolute value equations. This equation says that a number's distance from 0 is 3, and two numbers fit that bill, positive and negative 3. So if you want to look at that on a graph, it looks something like that. Now if we want to think about it as an inequality, this no longer says a number whose distance is 3. This is a set of numbers whose distances are less than or equal to 3. Again, that's a set of numbers whose distances from 0 are less than or equal to 3. So, if you want to look at it on a graph, it's all the numbers in between negative 3 and 3 inclusive, with a closed set, closed interval. This inequality right here says the set of numbers whose distance away from 0 is bigger than 3, greater than 3. So that's from 3 all the way to positive infinity, and from negative 3 all the way to negative infinity. Okay, now let's go ahead. I think we're ready to look at solving an absolute value inequality. So this says this quantity, which is represented by 3a minus 1, has a distance away from 0 less than 5. So we're going to put 5 and negative 5 on a number line. And we're going to stick 3a minus 1 as the quantity whose distance is in between the two. Now if we add 1 to everybody, you now have 3a is going to be in between negative 5 plus 1 is negative 4. And 5 plus 1 is 6. Then let's divide by 3, and a is going to be in between negative 4/3 and 2. And we can write that as a is less than or equal to 2 and greater than or equal to 4/3. Now let's take a look at the actual inequality and solve it algebraically. We're going to write this as two separate inequalities, and we're going to remove the absolute value bars. We're going to use the right hand side and just rewrite it as 3a minus 1 is less than 5. And now we're going to switch the inequality symbol and switch the sign of the number, and we're going to have 3a minus 1 is greater than negative 5. We're going to solve them each separately. Add 1 to both sides. We've got 3a is less than 6. Divide by 3, and we have a is less than 2. Now we're going to do this one. We're going to add 1 to both sides and get 3a is greater than negative 4. And dividing by 3, we have a is greater than negative 4/3. So we have a is less than 2, and a is greater than negative 4/3. Okay. By the way, I messed up over here. I used equal to. These are both less than. Okay. So now let's go ahead and take a look at another type of inequality. Let's take a look at, let me see, how about a really complicated one that you think might have to be a lot of work. Three times the absolute value of 2x minus 2 plus 2 is greater than or equal to negative 5. So let's go ahead, and before we go ahead and solve this inequality, we're going to have to clear away the positive 2 and the 3. Then we can go ahead and write it as two separate inequalities like we did up here. Let's go ahead and subtract 2 from both sides, and we're left with 3 times the absolute value of 2x minus 2 is greater than or equal to negative 7. And then divide by 3, and we have the absolute value of 2x minus 2 is greater than or equal to negative 7/3. Now, stop here because you don't have to do any more. Remember, absolute value is a distance, and we're talking about a distance from 0. Every number on the real number line has a distance away from 0 that's greater than 0 or 0. So any number in these bars will work. So this solution is all real numbers. Don't have to do any more, because distances are always bigger than 0 or 0 themselves. Let me get my S there. Now let's take a look at one more type of problem. Let's look at, let's see, let's try the absolute value of -5 minus a is greater than 4. A is a real popular number today, popular letter today, I guess. So there's nothing to clear away from outside the absolute value bars. So now we're just going to split it and write it as two separate inequalities. -5 minus a is greater than 4. And -5 minus a is less than -4. So we're going to add 5 to both sides. And we're going to have -a is greater than 9. And then divide by -1. And if you recall, whenever you multiply divide by -1, you switch the direction of the inequality symbol. Here we're going to add 5. And we're going to have -a is less than -4 plus 5 is 1. And divide by the negative, we're going to have a is greater than -1. So on the number line, if we were asked to graph it, we would need -9. We'd need -1. We can put 0 there for a reference. We have all the numbers that are less than -9, so that goes out that way. And all the numbers that are greater than -1, which goes out that way. Well, that ought to cover it for absolute value inequalities. Go ahead and rewind this thing and watch it as many times as you need to, or until you get tired of my voice.